Hi again, my name is Gene. Today we're gonna do some autonomous driving, so for this we'll need space. This is why we're in my garage. This is why I'm wearing a coat, because it's cold out here, and this is also why we have an April tag on the wall right behind me. Let's do it. Today what we have with us is a swerve robot with a camera in the front. But everything, or almost everything that we're gonna do today will also work on a tank robot, if you have a tank. And if you don't have a camera, only the visual stuff will not work for you. Everything else will still work if you don't have a camera. First of all, it's a good idea to start on GitHub, to start your team code on GitHub. If you have not done so yet, please sign up. I'm just going to sign in. Here we are. And this is how you start your team code for a season. What you can do is you can fork, which means to start from some other team code. So if you have a swerve robot, you can fork from our swerve template, and then you can add stuff on top of it. This is the link for the swerve template. And here is how you fork your code from it. You click the fork button, fork your own copy. And you can give it a name, for example, 2025 Pantera 714. Description: FRC 714, code for 2025 robot. How's that? Create fork. Now, if you are on tank, instead of using command ref swerve template, you can use our command ref tank template, which is the code for our tank template. You can do the same thing, click fork in here and enjoy. So let's go back to a new fork of the swerve code that was forked from the swerve template. This is the link to the code, and we're gonna start with this today for our autonomous driving. One important thing that I forgot. The whole point of using GitHub is so that multiple people can work on the same code. So we need to add everyone on the team as a collaborator. What you do is you go to settings in here, and inside of settings for your fork repository, you go to collaborators. And here you add everyone on the team. So everyone who wants to work on this should also be registered on GitHub. I'm going to add this team member as a collaborator. Select. Let's add another collaborator. We want to add everyone. Chaos Miller 99 maybe? Yes. Everyone in the team should be added as a collaborator to your fork of the repository, to your repo, as they say. And what's going to happen is each collaborator will receive an email like this. Hey, 714 Robotics, or whatever your name is, has invited you to collaborate. View invitation and accept invitation. And now a collaborator has accepted an invitation to work together on this code. Now let's start changing this code. We're gonna open PyCharm, and we're gonna take the link to this code. PyCharm is open, but I have some other project on there. So I go to the file menu at the top left and I say close project. I don't want to work on this project anymore. And now I have this button, get from VCS, or some of you will have another button here that says clone. So we're gonna click this button, get from VCS or clone, and we're gonna put in the link to the repository that we just forked. Clone. Okay, so after you have downloaded the code into your PyCharm, the first thing that you want to do is you want to go to the lower right corner of PyCharm and you want to say add new interpreter, add local interpreter, and we're going to add an interpreter based on Python 3.12. It's year 2025, so you should be using Python 3.12 unless you have a reason not to. I'm picking version of Python 3.12 and creating a new virtual environment. The second thing that you want to do while you're still connected to internet is you want to go to the requirements file in here, so you can click on the project view and pick the requirements file. These are the things that need to be downloaded for your robot code to work. They're all highlighted in yellow, and if you hover over one of them, you should be able to just click install all missing packages. In a single click, all of those things will be installed. If for some reason you cannot do this, you can go to here, lower left corner, and find terminal window. And in the terminal window, you can say pip install. Once it opens, you can punch in your terminal command, pip install -r requirements.txt, the name of this file. Hit enter, and all of those things that are needed to download before the robot can work, they will be downloaded. Done. At this point, the requirements are installed, and we should be able to deploy this code on a robot, or we can run it in simulation. You can run a simple robot simulation by choosing the sim option from here and hitting the run button. So I can run this code in simulation first. First time it runs, it will take a little bit of time. And it crashed. Why did it crash? Because I forgot to sync. Because I forgot to download everything else that it needs to download. So first we're going to run sync, which means download. Download some more dependencies. Now it says everything is downloaded. Press enter to continue. Enter. Now we should be able to run this code in sim. So I'm switching the configuration to simulation, and hitting the green run button. Perfect. Robot simulation is up. I have my joystick connected here. It's an Xbox joystick, it's just green. I can drag this Xbox joystick into joystick 0 position. And when I click buttons, I see that I'm getting input from the joystick. Very good. Time to deploy this code on a real robot. To deploy this on our real robot, first of all, I need to make sure that the robot is powered on. You can see it's powered on. Second, I need to connect to the robot's Wi-Fi, or I can do it through a cable, but I'm gonna connect to the robot's Wi-Fi network, FRC 714 in this case. And after we're connected to the robot Wi-Fi, I'm going to select the deploy option from here, deploy. And this code is getting deployed on the robot. First time it runs, it will ask for the team number or the robot host name. Okay, team number is 714 or whatever your team number is. And it's uploading the code onto the robot. Done. Deploy was successful. What I can do next is I can open the robot driving station, driver station, FRC driver station, and I should be able to drive this robot. If it doesn't work for you, most likely what's happening is your team number is not entered in the settings, in the setup and here. So go to your setup and enter your team number correctly. After you do that, you should see all lights are green here for the robot communication. I'm going to go to the joysticks tab, seeing the joystick that I have plugged in. Unplug. Very good. I should be able to drive the robot. Take a look. The robot is driving when I move the joystick. So we have downloaded the template for the Swerve robot and we have deployed it and it works. Now let's do some autonomous driving. So for autonomous driving, we're gonna need two tools. And the first one is called Path Planner. Download the FRC Path Planner in Google. Takes us to here, to the GitHub web page. And here, for manual installs, we can click on this link. This is what Path Planner is all about. You can plan the paths that your robot will drive autonomously, and they will be shown to you visually. And finally, if you want to download the latest version, 2025.00 beta 6 in my case, you just need to find assets. Here, I found the assets for this version. And I'm going to download Path Planner Windows 2025.00. It's downloading. After it's downloaded, you can click it and click through Setup. I already have it here. The second tool that we need to download is called Elastic. So I'm going to punch FRC Elastic. It's a very nice dashboard. It's a replacement for Shuffleboard. This is the official web page on the first robotics competition website, Elastic. It says that the detailed documentation for Elastic and all of the installation can be found here. So I'm going to click on this page. And look, right at the top, it says download. So this is where we can download Elastic. Okay, we're going to be downloading Elastic 2025.00. Elastic, Windows, Elastic Setup Windows. That's what we're going to download. If you have a Mac, there is Elastic Setup macOS. It's downloading. After you click through Setup, you will have it working. Okay, the robot is now powered on and Elastic is installed. So what we're going to do is we're going to open our Wi-Fi and connect to the robot. FRC 714. Connect automatically. Robot is connected, as you can see on the driving station, so let's open up Elastic. First thing we have to do is we have to go to settings and we have to go and punch in the team number, so Elastic can connect to the robot. And the IP address mode should be 10 team 2, like this. And now it says that Elastic is connected to the robot. Second thing we're going to do is we're going to start adding widgets to our dashboard. And the most important widget that we need to add is field. So I'm going to search for the robot field. Apparently it's inside of Smart Dashboard. Hi, this is Gene from the future. This is how you add the field widget. You click Add Widget in your Autonomous tab in here, and we go to Smart Dashboard, and we choose Field, and drag it all the way here. The other things we'll need to add are probably the heading of the robot, the X, and the Y. Close. Let's actually move the heading here, the X here, and the Y in here. Field, let's make it a little bigger by stretching it, just like this. Boom. And this is how you can see where the robot is on the field. Alright, take a look at my elastic. We have a field here depicted with a tiny little robot sitting in here at the coordinates of x 0 and y 0. Also heading in the 0 direction. 0 means north, and north in FRC is all the way to the right on an FRC field. Now I'm going to enable my robot, take my green joystick, and drive it. The robot is moving in my video, and the robot is also moving on the field, because the X is changing, and the Y might be also changing. When you drive it forward, the X goes up, and the Y mostly doesn't change. When you drive it to the right, or to the left, the robot is moving on an actual field, and the robot is also moving in reality, of course, and on my elastic field. We can see the X and Y of the robot changing. This will be pretty useful in planning the autonomous moves. Now let's do some autonomous path planning. To do path planning, we need to open Path Planner, which we just installed. And I encourage you to first go to Settings, App Settings, and disable holonomic mode. Holonomic is swerve or mechanism or any kind of drives that allow a robot to rotate independently from moving. But please disable holonomic mode at first. Close. Now we're going to go to the trajectories. Trajectories are all the way here on the left. We're going to add a new path, new trajectory. Where is it? No, new path. Let's call it example path. Here, they already have a path for the robot. You can click this button to switch the side of the field from red to blue. So this is the starting path that they are suggesting to us. It has a starting point in green and then has an ending point in green. So what I want to do is I want a path that the robot will take driving from this position, and you can see the actual points, waypoints. The starting point, I want the robot to be heading exactly 45 degrees, like this. I'm gonna hit the pause so we can see the starting position of the robot is 45 degrees. No, I don't want 45, I want 60 degrees. 60 degrees for the start point inside of the list of waypoints. And I want this robot to... I want to move this point a little closer to here and still be at 60 degrees. So I like this starting point a lot, I think. It lines up with what we wanted. And I want this robot to drive from here to this game piece on the center line. But in fact, what I also want to do is I want to add a waypoint right after the start point, in between this point and this point. So I'm gonna click the plus button, adding a waypoint in the middle. And I don't want the robot to hit this obstacle. I want the robot to kind of drive past here. And only maybe go. So I have added the start point, waypoint 1, this one, and then endpoint in this trajectory. And after waypoint 1, I also want to add another waypoint in here. So now we have a trajectory, and this trajectory has 4 waypoints. Okay, to summarize, we have created a trajectory for the robot to drive. It has a start point, and the start point has X, has a Y, and has a heading of 60 degrees. The robot is going to be starting pointing 60 degrees to the left. Then it has waypoint 1, this waypoint 2, and the last point in the trajectory. I'm actually going to move this a little closer because it might not fit in the garage. So this trajectory has 3 points, and each point has an X, Y, and a heading. And an endpoint of the trajectory that has an X, Y, and heading. At the end of the trajectory, we want the robot to look straight forward, straight to the north, and the north is to the right in FRC fields. Now let's go back to our Elastic, to the Autonomous tab, and we're going to add the widget to the Autonomous tab. We're going to open the Smart Dashboard, and from the Smart Dashboard, we're going to add the field, because it's fun. We're going to add the X and the Y over here. And the heading of the robot, heading. But we're also going to add something else. We're going to add chosen auto. Chosen auto is a selector. And there are some different autos to choose from. Left blue, left red, and trajectory example. So presumably we can add any auto we want, so long as we start doing it from the code. One last thing I wanted to show you is you can have this kind of chooser boxes shown as a split button instead, like this. So long as you click, right-click the widget and say, hey, I want it to be a combo box, and it becomes a drop-down combo box. Or you can say, I want it to be a split button, and it becomes a split button, in which you can choose different options for your auto. So now let's actually add different autos to choose from. For that, we need to go to the code. In fact, we're going to add the trajectory that we just created for the robot to drive. There is a link in the description to this web page with our autonomous driving and aiming command examples in Python. You can just copy them and paste. They are public under WPI license. The only thing you need to have is you need to have a robot that has odometry, which is the X and Y, like we saw before. Robot knew its location on the field with the X and the Y. You can go to the swerve drivetrain example that we are using here, or you can go to the tank or arcade drivetrain example, and most of the code below will work both with swerve and tank. Here we just have a swerve robot, but it doesn't really matter. It will work with tank. In order for the robot to drive the trajectory in question, we must put 3 must-have commands into this robot. First of all, we need a command to set the XY position of the robot on the field at the start of the game. So, and apparently it goes into commands / reset XY into this file. I'm gonna copy this, and I'm gonna go to my PyCharm. I'm going to the commands, going to the reset XY. Oh, I already have the code from here. The code in here, I just forgot that I already have it. Okay, never mind. If you don't have it, you can put it here. These are the 2 commands to reset the robot location at the start of the game. To, if you're red or if you're blue, where your position is. The second command that we must have is a command to get a robot to aim in a certain direction. For example, if you're dropping the game piece into the processor or into the reef, then you want the robot to point in a certain way. For example, point north, 0 degrees. This is the blue field, blue alliance north, or point south, 180 degrees, which is probably the north for the red alliance. So this is the command to point the robot in a particular direction during the autonomous or even during the game. and it must be put into commands / aim to direction. Let's do it. I'm going to the commands folder in here, and I'm creating a Python file called aim to direction.py. Add it to Git, yes. And I'm just gonna paste this code. Perfect. The other command that we need is for a robot to drive to a certain point on the field. Command is called go_to_point. You give it the X and the Y, and the robot will drive to that point autonomously. I'm gonna copy this code, and apparently it should go into commands / go_to_point.py. So we go to commands, we create a new Python file, go_to_point.py, and we literally paste the Python code example from Pantera right into here. This will allow our robot to turn in any direction we want on the map, aiming in a certain direction, and to go to any point on the field, either to pick up something or to drop something. Now, if you have a swerve robot, you can have another command. You can swerve to a point XY and also set your robot heading to point exactly where you want. Because on a swerve bot, you can swerve to the north while pointing to the west. That's possible for the swerve bot. The command is called swerve to point, and you should put it in a file called commands / swerve to point. So I'm gonna, because we have a swerve bot here, I'm gonna add this command to our menu. Swerve to point.py. It's very, very simple. It's not fancy. It only uses simple proportional control. Ta-da! We have added all of the must-have commands that we need for autonomous driving. Now, an optional command is to drive on a curved trajectory through a few waypoints. And remember, we have a fancy thing to do. We have a trajectory with 4 waypoints. So, okay, let's use the trajectory command also. This is a slightly jerky trajectory command because the robot will not drive very smoothly, but the code is very easy to read and it's going to go pretty fast. Jerky trajectory.py. This is how that file is supposed to be called. Commands / jerky trajectory.py. Okay, apparently I misspelled it. So if you misspelled something, you can just right-click this file like this and say refactor and rename. You can rename jerky trajectory into jerky_trajectory. And everything works. Now I'm just gonna copy the code for the jerky trajectory and put it into here. Ta-da! Now let's go back to Elastic. So inside of this autonomous tab, you can see that we can choose different types of autos. We can choose the left blue, we can choose the left red autonomous command, or we can choose a trajectory. I don't want any of these autos that somebody created for me. What I want is something else. I want to create 2 autos. One in which the robot goes from this green point straight to this red point, pretty much on a straight line or on an arc. And then turns down, which is, I guess, turns east. And the other auto that I want is I want to create an auto in which the robot goes from the green point through this waypoint, then through this waypoint, then through this waypoint, and finally to this red waypoint. And then also turns south. Let's try to add those 2 autos instead. To do all of this, we simply need to go back to PyCharm, go to our robot container class, and this is mostly what you will be editing for the competition. What we need to find is we need to find the function called configure autos. So take a moment until you can find it. This is the function where you add all sorts of autos, autonomous commands that your robot must have. So here, for example, to this chosen auto,
sendable chooser, we can add, look, it says chosen auto, right? We're adding a trajectory example, we're adding a left blue, and we're adding a left red auto. They kind of look like this. So this is get autonomous left blue, this one. It's a function that sets the start pose for the robot, and then just some sort of commands for the robot to drive. So let's get rid of them all. I don't want any of those. So we're going to have one default command. We're just going to follow what they did in here. Self dot chosen auto set default option. So this is presumably the blue alliance and the left position. So we can call it blue, left, straight to finish. So just going from green point straight to the orange point. Let's add this. So blue, right, straight. And we need to add the function self dot get blue right straight command. So the only thing that's left to do is to actually make the command for the robot to go from the green start point to the orange end point. To do this, we need to get this function name, which we just decided, and define, and we need to write such function in here, get blue right straight command. The first thing that you want to do in a command is you want to set the start pose of the robot. So the start pose of the robot in this case is this green point. If I click on it, the x is 0.773. Okay, x is 0.773. The y is 6.696. I can just copy that. And the heading in degrees is exactly 60 degrees. We're doing degrees because degrees are much easier for humans than radians. And we're going to use the robot drivetrain. And the second command that we need to add is the go to point command that we just added into here. So what we need to do is we need to say from commands dot go to point import go to point. And now we can use this command. We can call it go to finish equals go to point. And what is that finish point? The finish point is the x is 6.520. The y is 7.369. Drivetrain is self dot robot drive. That's all we need to do, really. We can also specify speed equals 0.5 if we wanted to go at 50% speed, but let's just make sure the robot goes at the fastest speed possible. And finally, what I want to do at the finish point here is I actually want robot to point down. I want it to point south, or not south, I'm sorry, this is east, if the right direction is north. So this will be minus 90 degrees. Okay, so we need a command that points the robot to a direction. We say from commands, aim to direction, import, aim to direction, and finally, aim west, aim east, aim down, we can say. Aim down is the command. Aim to direction, and we just need to say how many degrees. Degrees equals minus 90. Drivetrain equals self dot robot drive. And that's all we need to do. So now we have almost created our first autonomous command, which consists of three things. We set the start pose of the robot, then a command to go from the start green point to the finish orange point, and the command for the robot to aim its nose in that direction, downwards. which is minus 90 degrees on that field. All we have to do is we just need to create a command that joins all of them together. Set start pose dot, and then go to finish dot, and then aim down. Of course, in a real game, you would also be adding and then grab game piece or find game piece and something else. But just, for the sake of the example, let's just have those three commands together. Finally, at the end, this function must return the command that we have created. Return command. Very good. So now we have added an option for the robot to drive from the green point to the orange point, and this will be a selectable option in our elastic when we play with this robot on the field instead of those three options. One last thing, I probably want to put the word straight in the beginning of the command description, so it will say straight blue right. And I'm going to rename this function also get straight blue right. Get straight blue right command, just like this. But we also wanted to add a curvilinear trajectory for the robot to go from start to finish, right? So let's add another option. When you're adding an option to the chooser on the dashboard, you say add option. And instead of a straight blue right, we're going to call it a curved blue right. And the function will be called get curved blue right command. We're mostly going to copy this get straight blue right command to write that function, but we're going to make some changes. We have to call it get curved blue right command, right? The starting pose stays the same. The robot is still starting in this location, in this green location, right? But now, instead of going straight to the finish point, we are going to use a trajectory. So we're going to import a trajectory command from commands, jerky trajectory. We're going to import a command that's called jerky trajectory. And this will be our go to finish command. So go to finish equals jerky trajectory. What does this jerky trajectory command need? First of all, we need to give it which drivetrain we use. So we say drivetrain equals self.robot drive. Second, we need to give it the endpoint, the finishing point of the trajectory. Well, the endpoint we already have. What we want to do is we want to say the endpoint is 6.520, and you can just use a tuple like this, 7.369, and the heading in degrees and the endpoint is this. So we're going to say endpoint equals that. In addition to the endpoint, we need to give it something else. If I hover over this jerky trajectory, we need to give it the drivetrain, which we have done, the endpoint, which we have done, and the waypoints, which is going to be the list of points that the robot must go through. Okay, so waypoints equals, and when you make a list in Python, you must use square brackets like that. So the first waypoint in the trajectory will be my start point, 773, 6696. The second waypoint will be, and you can just give them by XY. Or if you don't want to give them by XY, you can also add heading. The second waypoint in the trajectory is waypoint number 1, 1.673, 7.191, and the heading in that waypoint is -48. And so on. We're going to add all the waypoints. Okay, so I have added all the waypoints for the trajectory in here. The first number is the x, the second is the y, and the third is the heading, which way the robot's nose should be pointing. Okay, what else did we forget? I'm just going to hover over this word again, jerky trajectory, hovering, hovering, hovering. So we have added the drivetrain, we have added the endpoint, we have added the waypoints. Now we need to choose swerve. Is it going to be a swerve robot? Or do we want it to drive like a tank robot? Because I have a swerve robot, I can choose swerve equals false or swerve equals true, whichever way I really want. And the last parameter that we need to add is the speed for the trajectory. Do we want it to drive slow or do we want it to drive fast? So I'm going to say swerve equals true because I have a swerve drive, even though I can choose and say swerve equals false, and it will drive anyway. And I need to set the speed for the trajectory. I can set it to 0.8 just for the sake of it. Even though 1.0 is totally fine, it will drive. So we have created the set start pose, we have created the go to finish, and we have created the aim down command. Now we just need to connect them together, set start pose dot and then go to finish dot and then aim down. And as a result, we have a command. So hopefully when we start elastic again, in our chosen auto, we will have two options: straight blue right and curved blue right. Let's see. In fact, let's just run it in simulation. Let's not even put it on a real robot. I'm going to switch to running it in simulation, and I'm going to hit this run button. Run. The robot simulation is up. The only trouble is Elastic says it is not connected because it is expecting that we're going to connect it to a real robot, not a simulated robot. What we need to do to connect Elastic to the simulated robot is we need to go to settings, just like so, and instead of connecting to a team number robot, we are going to connect it to localhost, which is my current computer. And now we're connected to the localhost. Let's see what kind of autos are available for us to choose. We can choose the curved blue right, or we can choose the straight blue right. And when the robot starts in the autonomous mode, it will either go straight from here, or it will go on a curve. Let me show you what happens if I start the simulated robot in autonomous mode now. Autonomous is started, and look where the robot is on the field. The robot is sitting here, just like we wanted, because we chose to start it from this point. The full simulation mechanics actually doesn't work, so it's not going to drive in simulation to here. But this is just shows that the autos that you can put together are pretty easy to do. Alright, so we have tested one autonomous command in simulation, and if you go back to PyCharm, you can see the code is still running. It has not crashed. This is good. Let's stop it, and let's start it in simulation again. But this time we will choose the other autonomous command, see if that works. I go back to Elastic, it is connected, and instead of curved blue right, I'm going to choose straight blue right command and test it in simulation again. So if you look at the Elastic window right now, the robot is not started yet, it's sitting at 0, 0. Now I switch it to the autonomous mode, and the straight blue right command works too. The robot is placed into this position on the field. It's just not driving because the simulation doesn't fully work. So we have tested both of the autonomous commands in simulation. It's time to put them on a real robot. I'm going back to PyCharm. I'm going to stop this code. And I'm going to switch it to deploy, which means we're ready to deploy it on a real robot. So what I need to do is I need to go to the settings on Elastic, and I'm going to say, no, no, no. Now I'm going to connect to the real robot, like this. Close. Then I need to go to PyCharm and switch from sim, which I had, to deploy configuration. And finally, I need to go back to the garage where the robot is sitting so that I can connect to the robot Wi-Fi and deploy this code there and run it. Now, obviously, we don't need these examples anymore. We can safely delete them. See you at the garage.
Okay, here we are. We are back in the garage. Go to our robot right now. We're gonna connect to it over Wi-Fi. Okay, connected already. Now, one last thing before we do this. Let's play it safe. Instead of driving at maximum speed, let's first drive at a very small speed, 0.2, in both of the autonomous commands that we had. Not 0.8, just 0.2. Just 0.2, yes. And even in the turn command, 0.2. Let's go at very, very, very slow speed. It's a good idea to be safe. So deploy this code to the real robot. Now, okay, deploy was successful. And what it means is our Elastic should now be connected to the robot. Just a reminder, what we should do is we should go to the settings of Elastic in here. We should punch in the team number and we should say that the IP address mode is going to be the team robot like this. Only then Elastic will connect to the robot. What we're going to do is we're going to select the straight blue right auto right now and then go to the driving station, go to the autonomous mode and see, will robot actually drive from this point to this point as we wanted in our path planner. We wanted the robot to drive from here to here. First, we're going to use the straight line autonomous. Switch to autonomous and enable. Now we're gonna try the curved trajectory, but still at slow speed, enabling in autonomous with the curved blue right chosen as our trajectory. Let's see what happens to the robot. It's going on a curve, just like we wanted, and stops. Exactly as we wanted, after making the right turn. We have verified that the robot can drive safely along the trajectories that we have chosen. Now let's try them at full speed. What we need to do is we need to go back to the code, and instead of speed of 0.2, we're gonna choose speed of 1.0. Speed of 1.0. And speed of 1.0 for all of our movement commands. And the robot should do the same thing, just a lot faster. Let's try it. First, we deploy the code with the new speed by hitting the deploy button here. Now the robot is in position. I'm gonna choose the straight blue right auto. In Elastic, I'm going to switch it to enable. It drove much faster and ended exactly where we wanted. Okay, the robot is back in the starting position. I'm switching it to the curved blue right autonomous. And please watch what's going to be happening on the Elastic screen. I'm switching the robot to the autonomous mode and enabling. Will it drive on a curve to the point that we wanted? Thanks for watching. Today we have learned how to use Elastic Dashboard, how to add new autonomous commands to it, and how to plan them out using Path Planner so that we can have coordinates X and Y. In the next video, we will continue autonomous driving, but we will be driving using visual navigation, using the robot cameras. Till then.